Let's look at example 3. So in example 3, here we have the question, what is the probability of obtaining 5 heads in a row when flipping a fair coin? Okay. So here we're looking for keywords. Okay. So far we have 2 keywords, the keyword or, the keyword and. Okay. This question is asking to find the probability of obtaining 5 heads in a row. So 5 heads in a row. But similar to the question before, I'm not seeing a keyword here, right? So we need to see what 5 heads in a row really means. That means if you're going to get 5 heads in a row when you're flipping a fair coin, that means that the first coin was heads and the second coin was heads. Is that right? And if we keep going, the fifth was heads. Okay? So here we have these events occurring with the keyword and. Okay? Now, the question is, first of all, let's give these events names. Let's call this A. We can call this A1. We can call this A2. This one we can call A5. Okay? So we have the probability of A1 and A2 and all the way through A5. The question, similar to before. The keyword or, we have a formula for it. We can expand this multiplication rule into 5 events. It's multiplying the individual probabilities only if we have independence. So let's just take 2 coins, okay, for now. So imagine you have one coin in one hand, the other coin in the other. And you flip your first coin. The outcome is whatever it wants to be. And then you take your other hand and you flip that coin as well. Will that second coin flip change in probability based on the outcome that occurred in the first? The answer is no. Each coin, each fair coin is still 50-50, right? Just because we get heads on the first coin toss doesn't mean that the probability changes in the second coin toss. The second coin toss is still 50-50. And that applies for all 5 coins, right? So the question is, if we have independence, here we do. So we can expand this definition, okay, to say by independence, we have the probability of the first event occurring, the first coin being heads, multiply that by the individual probability that the second coin is heads, and we're going to take this all the way through the fifth coin being heads. Okay. So here I'm going to give you kind of a short notation on how to write 5 heads in a row, because sometimes a problem can say 10 heads in a row, 20 heads in a row, and that can be very lengthy whenever we're writing each individual probability on paper. So I'm going to give you kind of a shorthand notation to write this equation. So here, the probability that the first coin is heads, that's going to be 50%. Is that right? Times the probability that the second coin toss is heads, very similar, 50%. And the question is, how many times are we going to write this 50%? We're going to write it out 5 times, right? So when you're multiplying, okay, we can shorthand write multiplication using exponents. So 50% becomes the base, and how many times are we going to write this base out? 5 times, okay? So whenever you calculate this probability, that will give you the probability of obtaining 5 heads in a row, and it should be 0, 3, 1, 2, 5.